All right. So here we are actually starting the real work. The week one, as I call it, where primarily we wanted to cover three major topics. And again, it's to start with, it's theoretical, and then we'll get into some of the practicalities of it. But what we call the AI, the ML, and the data science part of it, or the fast lane, or the real reason why you all are here, right? So when we say AI, I know in the survey when we asked about, some of you had answered the real AI life use cases. I want to open up the floor again and just want to ask, what do you understand from an AI point of view, a real use case you may have seen in real life? Anybody wants to jump in?
Yeah, one example I can provide is autopilot in the
Autopilot.
cars.
Okay, autopilot in the car. I see. Okay, okay, good point. Sorry, it should be this way. Going too fast. Yep, autopilot in the car. Okay. What do you understand by autopilot in car? What exactly it is doing? Why it's AI?
So it's actually initially we'll have the software um actually without the proper knowledge on the roads and other, but it will have the sensors and everything working together. It will grasp, it will see everywhere, like the signals, like the pedestrian crossing,
Hmm.
uh, and the speed limit, and the auto braking system, everything. So once it is started driving itself and actively driving, so initially we can say like machine learning is zero at the level of zero, and then it'll improvise itself with the different use cases. And when more users are using the autopilot, it'll have the information, it'll have the previous knowledge, previous cases, and it'll apply based on the use cases. So it is self-improvising system, and it is artificial intelligence plus machine learning. Probably, I think it's deep learning. Everything working together in the autopilot.
Yeah, yeah, no, that's a very good analogy in a way. So yes, you are correct in a way where it is artificial intelligence, it is machine learning, it is deep learning, and quite a bit of it. And so if we have to define AI, and AI is in everyday life, like the car, what you talked about is one example. But those who don't have Teslas or some of those smart cars, if we think from that angle, your phone has Alexa or Google Voice or Siri, right? That's AI in your hand in a way, right? Where you are saying something and it's doing it for you, right? So when we think of AI, it's like science and engineering. This is the John McCarthy definition, but it's the science and engineering of making intelligent machine, and it's from 1956, and it's still true in a way where even after 50 years, or maybe more than 50 years now, it's like almost 65 years, something like that, or 75 years. It's still true in a way where we are trying to make more intelligent machines. And hopefully, in this decade, we will have those intelligent machines which are kind of replacing human for many of those workload, or I should say, augmenting human, not replacing human, but augmenting human for quite a lot of those activities. Driving is one of that, and it's not always easy to drive in a rainy or a snowy days. It's great to have a drive in the sunny and a straight road, but at the moment you see a darkness or a curve or whatnot, and then how that intelligence is being created and how that the entire mapping is being defined, it's phenomenal. The way either Tesla or any of the other car manufacturers are doing. But if we go from academia point of view, right? Typically, we define this AI in three category. One is called artificial narrow intelligence, And it's also sort of known as weak AI, right? And weak AI is exist today, right? I mean, if we think from that Alexa use case, what we are looking at, it's definitely in a way we are using a weak AI, where that AI is sort of programmed to do a specific task, and then maybe quite often it's a single task, right? Whether it's looking at the weather, or whether you are a chess player and want to have a computer player chess against you, analyzing multiple things, or if you are a writer and you want to review some of the reports and you want to generate something to start with. In that sense, we call that more of a weak AI, right? And then when we move from the weak AI or the general intelligence, is I think we are almost getting there to what we call the general intelligence as a part of AI, because AI has been evolving for almost a decade, I would say, and decade because there are many history behind it. One is the emergence of cloud computing, right? Because probably 10 years ago, there was no major cloud providers existed. Yes, there was AWS and there was some Google Cloud and some Azure Cloud, but overall, the demand for cloud computing sort of spiked, I would say, 2012, 2013 onwards. And that made two things, right? One, it made competition, where it's not only the Dell or HPs or the Lenovo and IBM, the world are building the hardwares. Other companies had started building those hardwares, including Google, Amazon, and many others. So that means there is a competition in terms of building a better hardware. And as there is a competition and there is a better hardware is being developed, that means it's becoming cheaper, because competition breeds the reducing the cost and whatnot. Along with that, as the compute became cheaper, along with it became easier to consume, right? Maybe you can have, if you are a large company, let's say a huge bank, you may have a big buying power and you can ask HP or Dell to reduce the compute price for you. But to normal person like you or me, if we get access to that compute in a second, like what you just did last week, right, where you launch an EC2 and then within few seconds you have that EC2 VM ready, and if you want to do anything on that EC2 VM, it's there available for you to start working, right? Yes, there is a cost, but that cost is very minimal when we think of overall in the large scheme of things. So what made happen is with the emergence of cloud, with emergence of multiple hardware options, it became compute became available to a smaller companies or startups or new breed of companies. And what it allowed us as a generation to do is many more companies started developing around what we call now the AI and ML, right? And probably in 2014, if my timeline is correct, when AlexaNet or AlexNet, I think not AlexaNet, AlexNet was one of the group of scientists. They actually created a model where they detected images, and then their model performed way better than any of earlier model have been performed from an object detection point of view. So when we say object detection, I'm diverting here, but if you take a picture and if that picture has a car, has an animal, has a human, and if your model is able to detect those three items, for example, out of that picture, it's nothing but an object detection. And it's part of that artificial intelligence, where if your model, if your computer is able to identify what's in the picture, that means if we can scale it to 1,000 times, and if we're detecting in real time what's in the video, That means you can create many more use cases. So that AlexNet actually opened up door, and then they made that everything open source, right? Open source is the enabler for many of this AI, what we see in today's world. But where I'm going is what we have started seeing is many of the use cases moving from narrow intelligence to a general intelligence. And when I say general intelligence is if you ask a model, and when I say model, think of it as a computer. If you ask a computer to do certain tasks, it will do it for you in jiffy, right? It might, like a mainframe, if you ask something mainframe to do, it will do it, but it will take ages. And then again, those who don't know mainframe, that's okay. It used to be a room full of computers, and you ask that mainframe to do some sort of a data processing, and it will come with the result in few hours saying that, hey, you gave me 1 terabyte of data, I compile the data, and after a few hours, hey, here is your data crunched result, right? So in the mainframe ages, it take longer, and then that is where I think the AI or the general intelligence is going, where we have results in few seconds to few minutes, depends on what we are asking to do. So one example, if I think from a general intelligence point of view, is a company called OpenAI, where they created few models from AI point of view. One is called GPT-3. GPT-3 is a model where, in particularly, helped many of the author, and it's still helping. I'm not saying help, but it's helping in real time right now. Is where you prompt something to that model, and then that prompt, it's taking that prompt from you, and in few seconds, it's generating an entire text. So the text could be a paragraph, or it could be an entire article, right? So it depends on what you're asking and how long the data you are asking it to generate. In few seconds, it might generate a paragraph, and if you wait few more seconds, it might generate an entire article. So how this helps, like if you think of CNN or CNBC or any of those news companies, right, where they have hundreds or even thousands of reporters, and now if they have this kind of model, they don't need thousands of reporters, right? They can simply ask this model to say, hey, something happened in somewhere world, go and create me an article, and that model will generate an article, and they can publish it on their website, and people will read it, right? So that's where the general intelligence is sort of going. Another thing they created, OpenAI, again, I'm talking about, is the DALI. So some of you may have heard a Disney movie called Wall-E, Wall-E. And it was a robotic movie in a way. And taking an inspiration from that, they created a model named as a DALI. It's a text to image, right? So if you ask that model that, hey, Ritesh is sitting on a horse and moving in a sky, right? You just prompt this kind of a few words, and that model will create an image of Ritesh. I don't know from where it's going to find an image of Ritesh, but it will definitely find an image of horse. It will definitely find an image of sky, and put Ritesh is on top of horse, and then somehow portray that image that horse is flying on a sky somewhere, right? So that's DALI. They created DALI version 2 as well. So it's called DALI 2. And then some of you may have heard of it. That's fine as well. But if we look at this two example, whether GPT-3 or DALI 2, both created by OpenAI, but what I would call that is more of a closed source system. And when I say closed source, it's you as a user, or I as a user, if I have access to either GPT-3 or to DALI 2, all I'm doing is I'm making an API call, REST API call, or in a way, right? And I'm asking that mod to API to give me a result, right? So it's a black box in a way to start with. They have a mechanism commercially where you can fine tune your models and whatnot. But recently, a company called Stability AI, they took it different approach, and that's where I think the innovations are happening. Where Stability AI created something called Stable Diffusion, and it's similar to DALI model in a way, where it is still text to image, but it's open source, right? And when we say it's open source, that means you, me, anybody can take that code as is, run that model, or take that model and fine tune with our data whatever we want, or use it as is, doesn't matter, and generate an image from that text. And if you want to change, you don't like how that Stable Diffusion is producing those images, excuse me, you can change that underlying data. You can fine tune that model and so forth, right? So if we think from, let's say, if I'm not saying that I'm Adobe, but I'm sure most of you are familiar with company called Adobe, right? Adobe has a lot of creative suites, and or if I'm like a Getty Image, where probably any image out in the internet is I would say 80% of those images are owned by Getty Images, and quite often, if you are using some of those images from which is licensed by Getty, then you have to pay some fee to Getty, maybe a cent or 2 or 5 cents or whatnot, right? But with this kind of model, suddenly your images are being developed by you, right? You as a creator. If you are a creator and you create that image, you own that right at the end of the day, and you don't have to pay anything to Getty Images. Or if you are an author, or if you are a reporter, and if you are using that GPT-3 model with take some 35 characters from Twitter, for example, and create a story out of it, whatever that story looks like. I'm sure people will read it because it's English language at the end of the day, and people are reading English language. So that's where I think the general intelligence is going. Again, I'm not saying that general intelligence is here, but it looks like it's getting there, right? So at some point in our lifetime, definitely in my lifetime, I'm going to see that general intelligence taking off heavily. And maybe this decade is the decade where we will see that general intelligence taking off, and then we might see a very neat use cases coming out of our way. And the super intelligence is literally replacing human. It's like a sci-fi movie. Any Hollywood sci-fi movie you will see, and then probably you will realize it's still going to take time. Maybe in my lifetime, maybe in your lifetime, and then we will see how we end up. But this is where the AI is going. It's happening, and with that, I'll take a pause. I know I spoke a lot for like 15-20 minutes, but I want to see if any questions anybody has on this topic.
No questions.
Okay. So question to all of you, have you heard of those terms like GPT-3 or DALI or Stable Diffusion?
I haven't.
Okay.
Me too. I also have not heard.
I also never heard of them.
Okay. But were you, so based on what I was explaining, at least were you able to grasp what it does?
Yes.
Yeah.
Yes.
Okay. So what we will do is, as an offline mechanism, right? We'll share some of the public blogs where they are talking about GPT-3 or DALI 2, or even I'll share the GitHub link for the Stable Diffusion, and show you an example where you can run your own Stable Diffusion on top of your even EC2 instance, right? And you can generate your own images if you prefer. So that's where the AI or what we call the general intelligence is going on. But it's an overall AI. When we think of AI, is a broad umbrella, right? And then that's where I think.
In progress.
Okay, I think Yanni switch from mobile to laptop.
Yes. Sorry.
Yep, no worries, no worries. So when we think of AI, it's a broader term, right? And particularly when we think what's happening behind the scene is actually we are sort of training that machine, right? We are training that computer. That hey, computer, do this for me, right? Computer doesn't know, and we are sort of teaching computer that do this and do that, and that's how computer is learning, right? And that is the subset of AI. It's called machine learning, where in a way we are explaining, we are feeding. It's like a dog training. I don't know whether any of you have a dog. I mean, my dog, it's bit trained, but I would still, he still doesn't get a lot of things. Sometimes he sits, sometimes he doesn't. But similar to that, when we say machine learning, we are sort of asking machine to learn how it happens. It practically happens in if we think from a categorically point of view, there are three categories. One is called supervised learning. The other is called unsupervised learning. And the third is called reinforcement learning. So when we say supervised learning, I think what we are doing right now, you are learning machine learning and ML ops and AI and whatnot. And me and Shri are sort of your teacher in a way. So we are supervising you and we are teaching you that this is right or this is wrong, right? Like you should not have 0.0.0.0 in your SSH access. You should have your public IP only /32. So we kind of taught you, and now you know it. And then you failed it, Nishit, once, and you fixed it. So you sort of reinforce in your brain now. So I know whether you got my pun here, but supervised learning is in a way where supervisor is or somebody is teaching you, or we are teaching machine that, hey, this is, we are showing a picture of 100 dogs and telling machine that this is dog, this is dog, this is dog. And similarly, we are showing a picture of 100 cats and telling the machine that this is cat, this is cat, this is cat. And when we bring up a picture 101, for example, and it could be dog or it could be cat, and we expect that machine to recognize whether it's a dog or cat. So in a way, if machine is recognizing, and then if we are training the model correctly, it will have a better accuracy, and it will show you that this is a dog and it's not a cat, or this is a cat and it's not a dog. Right. So in a way, machine is predicting correctly, and then machine is learning if it predicts correctly. There are, and then believe me, 100 images are not enough to teach machine if we are starting from scratch. Probably 1,000, maybe more, and in variety of dogs, because dog has what? How many breeds dog have? Maybe 100, maybe 1,000, I don't know. And there is an entire data set of those images from a public point of view, where you can grab those images from public domain and you can start training your model or building your model with a training saying that, hey, this is a dog, because I'm teaching you, go and understand, go and see this image, go and see this image, this is a dog. Like we as a human learn, right? This is mama, this is papa, this is uncle, this is aunt. Similarly, it's supervised learning from a machine learning point of view. Any question before I jump to unsupervised?
No.
Okay.
No.
Okay, thank you. So when we say unsupervised, it's in a way where we will throw you in a pool and we will let you go. So one second, am I sharing machine learning slide, or it's an AI slide, or it's not moving?
Oh, yeah.
It's
Now
a-
it moved to supervised learning test. Yes, yes. Yeah.
Okay, you see, I mean, it's still one slide, machine learning.
Okay.
I'm not,
Okay.
I don't have, again, for simplicity, I don't have each subsequent slide of supervised versus unsupervised and whatnot.
Got it. Got it. Got it.
Okay. Yeah, cool. So when we say unsupervised, it's like we throw you in a pool and you start swimming, right? or that's how it goes, where you throw somebody in a pool and then they'll start swimming. Similarly, unsupervised learning is where we are throwing the bunch of data to this computer or to this model, and we are expecting to learn on its own, right? And there are use cases where machine can learn on its own based on the subset of data. So like anomaly detection could be one area we can think of where we want to say, okay, find an anomaly. In that scenario, you will have like 10,000 data. And if you want to identify what is your anomaly, and computer will start thinking in that sense, okay, where is my anomaly? And then based on that, it will start learning, okay, this is where anomaly is, and this is where I need to start finding those anomalies. And there are another use cases we can think of when we say unsupervised learning is identifying a cluster of group, right? And then when we say cluster of group is if we have a data set of girls and boys, for example, or male and female, and if we set sort of give that data set to a model and say, okay, go and find me a male and go and find me a female from this data set, most likely it will go and look at that data set and then try to create a segment of the data that, okay, out of this, I'm going to classify this as a male, this as a female, or whatnot, right? So there are use cases where if we want to define certain customer segment, or if we want to sort of create certain groups, that's where unsupervised machine learning comes in picture, and then it's very effective in those examples. Any question before we jump on to the reinforcement learning?
So,
No.
Ritesh, I say if you have to ask, do we have any live examples that we can talk about between supervised and unsupervised, like to help understand?
So when we say a live example, right, if you want to identify, and then I'll take an example of unsupervised learning, for example, and then we'll go to the supervised. But everyone remembers COVID, right? There was a thing called COVID-19.
Yeah.
Yes, we
Okay,
do.
all right. So quite often, and then we are in technology, so we are tech savvy, and then we've been doing online shopping for a few years now. But there were many people who did not do online shopping, right? They relied on the local shops, whether it's your local supermarket or even your local shops, to go and buy the groceries, to go and buy even toilet paper for that matter, right? And when that thing called COVID-19 happened, quite a lot of people ended up going to online. Think of any e-commerce website. You can think of Amazon, Walmart.com, Costco.com, Target.com, doesn't matter, right? And when you are buying something from your local store using your credit card versus when you are buying something in an online using your credit card, this credit card companies, doesn't matter what they are, Visa, MasterCard, Amex, you name it, they have a different set of models because they consider, let's say, if I don't do online shopping at all, I'm in a different category from a risk point of view, versus if I do online shopping and local shopping, I'm in a different category from a risk point of view. So during that COVID-19, when everyone was buying things online, that means those users who were typically shopping locally and not doing online shopping, or maybe doing 1%, 5% of the online shopping, suddenly started doing 30, 40, 50, even 100% online shopping. It literally flagged their model, and they consider this as an anomaly. right? Because it is an anomaly in a way. And when we say anomaly, it's like something which flags out, right? Which is if you have everything of green and suddenly you put red color, your red will flag out. Or if you have everything red and then you put white color on it, your white will flag out, right? Similarly, this credit card company's model, which kind of checking whether somebody is doing fraud or not, those model kind of spiked up. And they said this is a fraud because this guy never did online shopping, or they only did online shopping once a year or once a month. And then he's doing 3 times, 5 times, 7 times a month. So that sort of highlighted as more of an anomaly in their model, right? Or in their prediction. And they started rejecting those transactions. Now, that's an anomaly. And then that was done using unsupervised machine learning model in a way, because the model is trying to find out something which is outside of norm, and which is what we just example heard is completely outside of a norm, because those users were never doing that much online shopping. Does that help from a unsupervised machine learning point of view, at least the use case?
Yeah, Ritesh, yeah, definitely. Like, say, for example, when you're talking about it, say, I thought of something, right? Like, say, for example, when I go to a grocery store and I keep buying certain types of items from the grocery store. So now, if the grocery store happen to learn based on my purchases and items, and if it learns on everybody's items, so it can give them idea of what item is fast selling, what is slow selling, on which day, which item might be what do you call sold at a certain rate, correct? Would that help? Is that similar to what?
That is a next level of supervised learning, and it's a combination of unsupervised learning, and it's a combination of unsupervised learning plus some sort of a recommendation engine, right?
Got it.
Where it's learning your pattern,
right,
and recommending you, or maybe suggesting that you should do X or do Y, right?
Yeah.
But clearly the example is because credit card company needs to watch out for fraud, right? And then particularly with online, there are a lot of fraud happening, and they have that kind of model defined where we want to watch for fraud for online shopping. And then that's reason many of these users, I mean, not only in India, but throughout the world, right? If we look at from the COVID-19 point of view, most people started doing that online shopping, whether it's here in US, or if we think from India point of view, literally everywhere those models were like going off the chart.
Right.
Okay, so the reverse example of supervised is more of as I gave earlier, right? The cat versus dog, where you feed maybe even 10,000 images of cat, and if you show a tiger, it's possible that it might consider that as a cat, because if you think from a picture point of view, a picture of tiger and picture of cat, there may be a lot of similarities, right? So that's your supervised learning versus unsupervised learning. Before we move on to reinforcement, any other question?
No, Ritesh, I think that's also ask for again.
So basically, an unsupervised, like it will be like a trial and error. Is that what it does over there? Unsupervised learning?
In a way, it is a trial and error. But what model is trying to do is it's trying to create like component together. So it will create a cluster of similar data, right? And it will find an outlier that this data is not similar to what other data I have. So let's say if we throw 100, I want to say, Okay, and this is a bad example. I'm precursoring this, but let's say if if an engine is doing a loan processing, right, hypothetically speaking, and if that loan processing system is asking for your race, that you are black or white from a race point of view, and if as a part of that, it's identifying that 99 out of 100 is white and 1% is a black, it will outright reject that loan. Now that is a bias in that loan processing. But in this scenario, all it's doing is using that field as a race and the value of that field, and it's creating sort of a two, let's say, subset of the data. The one set is all with similar value. So in this case, it is white and the outlier is a black. Or it could be vice versa, where if your value is higher in black, then it will say, okay, there is 99 black and 1 white. And it's going to make the decision based on whatever decision factor has been assigned. But at the end of the day, what unsupervised machine learning is doing is creating that segment, whichever way you are asking it to create. So you feed the data and it will tell, okay, for this field, this is a segment where 99 people are white and 1% is black. Does that help, Salman, from an example point of view?
Yeah, Ritesh, it does. Because
Okay.
I was also thinking that in reinforcement learning, it will also do like trial and error, but over there it will perform the actions which give the maximum reward or something.
Correct. So that's the right way. So let's jump into reinforcement then now. Yes. So reinforcement learning is it's exactly, I think, Nishit learned over the weekend or whenever, yesterday, where you sort of teach your model by trial and error, exactly what Salman you said, where you sort of penalize your model if it fails, and you give them some sort of a reward if it performs in the right way, right? So there is a thing called reward function, where as a part of that, let's say your autonomous car is primarily based on reinforcement learning, where your that engine or the model has been trained to operate in a certain condition, right? And that condition could be an entire map of US. Okay, I'm just saying. And that entire map of US has been thrown at him, and that model have learned an entire map of US, and it has understood how to navigate the map of the US, where to take the right turn, where to take a left turn. Now, when it's supposed to take a right turn, and if it doesn't take a right turn, that means it's making a mistake, then you don't reward it. But when it takes a right turn where it's supposed to take a right turn, you reward it. And somehow you create that kind of a reinforcement in that model, saying that you are doing good things, you are doing good things, and you keep learning again. You keep learning again. If you fail, you try again. If you fail, you try again. And similarly, what most of you grew up in India, where we sort of learn many of our primary lessons via reinforcement learning, where the tables of 1 to 10 or 1 to 20 depends on how you started learning. It's by repetition, right? And if you fail, your teacher is gonna smack you on your hand or whatnot, at least in nowadays. But that's a reinforcement learning, where you reward a user, or rather a model, for making a successful attempt, and you ask them to restart when they fail. Questions?
No questions.
Okay, Nishit, Gyani, I know you've been quietly listening both.
Yeah, I have a question. So when we have the unsupervised learning, right? Why do we still need supervised learning?
When we have unsupervised learning, why do we need a supervised? Oh, okay. Yeah. So think of unsupervised learning is a use case where you have only got anomaly out of the data, or you got a segment out of the data, right? But you don't have the actual result, right? So if I was giving that example of black and white, think of black and white color, right? And then the model has black color, model has a white, the data has a black color as well as white color. And the picture, like 100 pictures out of 100, 80 are black, 20 are white, or some sort of a shade of black and white. So this model will segregate the data for you, but it's still 80 and 20 based on whatever the segment it created. Now, it doesn't know what this data entail behind the scene, right? And that is where you need to train that model in a way with certain supervision that, okay, out of this 80 model, or sorry, out of this 80 data set, some are gray, they are not white or black. It's possible, right? And model may have identified them as differently. So another use case I can think of from there are so many use cases from a supervised learning point of view, but that cat and dog example, if we go back to that cat and dog example, where machine needs to know when there is a cat and when there is a dog. And that is what we are feeding the machine, that, okay, this is the cat, this is the dog, based on the image, based on the data, the text, that this is the word. If we use the word, let's say Nishid, and if I feed that word Nishid to my model, in this case of supervised learning, and the model is all it's doing is creating names, right? And if I give 100 names to this model, Nishit, Salman, Ritesh, Gyani, Sri, in different fashion. So the very first letter this model is learning is N. And the next letter that model is learning is I. That means the model now knows that N and I are part of a name. And if I feed the third letter NIS, then it's learning, okay, NIS is part of a name. So similarly, I'm teaching the model that it's not just NIS, it's the entire 7 letter, or it could be 8, sorry. The entire 7 letters is part of the name, or maybe in this case of Sri, it's SRI are the part of the name, and that machine is learning that, okay, SRI is a name. Now, if I ask that model to generate a name using any 3 letter, like N and S and R, it's going to come up with some random mechanism based on whatever it learned from that earlier example, right? If we are giving him 100 different example, and if there is a sequence, it is learning that sequence model, then it's going to show you the exact use case or exact mechanism of how that name is being produced. Am I clear, or am I mumbling and I'm not giving you the right
No,
answer?
it is you're very clear. It is. So just to see if I have to what do you call repeat that is, say for example, for a supervised learning, what we're doing is we are teaching the system with a training data set, right? Some data, what we want it to, and the goal for that training is already known. Like for example, if we input a lot of dog pictures and train the model, we know what the output is, meaning the system is about to learn what a dog might look like, correct?
Yep.
That's a supervised learning. And now for the unsupervised learning, the output is not known. It has to come up with some associations. It has to understand what is the data. It has to classify what the data it learned. Am I Am I close?
Yes, you are 100% there. It's in one scenario the output is known. In the other scenario, output is unknown.
Exactly. Yep. And for the in terms of for the supervised learning and unsupervised learning, the places where we apply them are totally different. Like for example, supervised learning, we mostly use to classify things. I mean, at higher level, yes, there are other use cases as well, but classification is the best example for supervised learning. And trying to kind of come up with some associations of the data that is found is the best example for unsupervised learning, right? Again, this is what I understood from the past session.
Yeah, no, and so yes, that's true. Where classification is one example.
Exactly. Yes, only one example. Yeah.
Prediction is another example, right? So when we say classification, it's the dog versus cat. That is classification.
Yeah,
right?
exactly. Yep.
Versus prediction is Zillow. Are you all familiar with Zillow?
Yeah.
Yeah. Right. So Zillow is a website where all of the US housing data is there, right? And and literally they predict the house price in a way based on and then there are funny story about Zillow predicting house price and whatnot. So that's the reason I think I'm and Sri as well in a way laughing. But that's where the AI goes bad, and then you will have a lot of trouble. But that prediction or predicting of house price based on multiple factor, that would be one use case if we think from supervised learning.
Yeah.
Because in that scenario, that model needs to know how many bedrooms, how many bathrooms, is your basement finished? Does it have a backyard? How large is the backyard, right? So there are many data points model has to learn, and based on that, it has to infer. And along with that, what is the neighborhood pricing, right? If your neighborhood is in Michigan or is in New York City, based on that, it's gonna identify. Or if we think from a weather point of view, right? What is that weather looks like tomorrow, right? That's a prediction, and that prediction depends on many factors, along with what it was exactly same date last year, a year before, or 20 years before, right? Plus what other factors are going around in the neighborhood. Is there a hurricane season? Then how that weather is going to look like from 3 days from today and whatnot, right? So there are many use cases we can think of, and we are not aware of, are already being applied as an ML, as a supervised learning, right?
Yeah, true. And one more thing is, I think this is from what you've been explaining, this what I understood, right? So to me, based on what you're explaining, I think supervised is less complex when compared to unsupervised because the data set is known, the outcome is known. Is that a fair understanding?
In a way, yes, but if we think from a different angle point of view, particularly when we want to reduce the complexity, that's when we use unsupervised.
Right. Okay.
To start with, right? Where we got, again, if I go back to that housing data, for example, right? And if I want to, before I want to do even prediction algorithm, I want to know which neighborhood has $1 million and higher homes, right? And which neighborhood has $1 million or less home, right? So in that scenario, I'm just creating two segments, that million plus or million and less, right? So in that scenario, I'm sort of reducing that complexity from my data set, and then I can feed that to my model, which is a supervised model, that go and predict that the house price which are higher than $1 million, and go and predict the house price in a data set which is less than $1 million.
Yep.
Cool. And finally, the reinforcement we touched upon, but any question on reinforcement before we, I think I forgot who asked that last question, but Nishit, that was you, I believe.
Yeah, I asked that question. So for some reason, I feel like these are all like stages of a machine learning. So when we start some machine learning framework, we need to start with supervised learning, right? So after that, once it is self-sufficient, we might have to open up that to the unsupervised learning. Then it will go for the reinforcement learning. Is it something like that, or we'll have separate framework for each individual scenario, like supervised learning? We'll have some kind of machine learning algorithm, which is not smart enough to act as unsupervised learning later.
Yeah, you are right. So in a way, yes, there are different algorithms exist for different functionality, right? And I know this course is not supposed to be going into the details of those algorithms, but we will at least touch upon some of those algorithms, what are commonly used, right? And then we'll review them. Like I'll take an example. We were talking about anomaly detection, right? Which is there is an algorithm called random cut forest, and that is primarily used for that kind of anomaly detection, or the classification, or some of the prediction algorithm. What we are talking about is XGBoost. And I would say XGBoost is like a Swiss Army knife in a way, where you can use XGBoost for most of the functionality, quite likely. But again, we'll go through some of those algorithms where each use case has its own algorithm developed, so that you don't use like your large knife to cut the small vegetable, and you use your small knife to cut your large vegetable, if I use that term correctly, right? That way you are not misusing that algorithm in a incorrect way. Okay. All right, moving on. Okay, to move on to the next slide. It's very easy, simple. Hopefully I remember this. Okay. So this slide is very simple in a way. I just wanted to highlight some of the terminology you will come across as a part of our MLOps functionality or MLOps course. NLP, any of you heard of NLP?
Yeah, it's natural language processing.
Correct. What is it?
I mean, I think it's like it includes like speech recognition and then speech processing and all that. If I'm not
Very
wrong,
good.
I don't exactly know.
No, you are spot on. It is in that direction. Directionally, you are correct. Okay, so when we say NLP, it's natural language processing, and primarily speaking, when we talk about NLP, it's anything to do with text. So what I'm speaking is nothing but a text, right? If we convert this speech into text, at the end of the day, that becomes text, right? So when we think of NLP or natural language processing, the use cases are enormous. And when I say enormous, endless. We briefly touched upon that GPT-3 example, but GPT-3 is the far end of the spectrum, right? If I have to give you a very simple example of Alexa, I'm assuming all of you have used either Alexa or Siri or something, right?
Yes, yeah.
Okay. So anybody who wants to care what happens when you say, hey, Alexa, or hey, Siri? I hope my phone Alexa is off. Yeah, it is off. Anybody wants to walk me through what happens? Hey, Alexa, what's the weather tomorrow? Let's say.
Yeah, I think it will first like record it and then convert that into text. And then it will like go through the text and perform it will find the keywords and then perform the action.
Okay. You are very close. You want to close that, how it give you the answer?
I'm not exactly sure. I mean, how it
Okay.
does the final process.
Okay. All right. So in a way, when we think from, again, I'm not saying this is how exactly Alexa works, right? I don't know from a real engine behind it, but in general terms, this is how it works. When you say, "Hey Alexa, what's the weather tomorrow?" Right? So first you are using that wake word, "Hey Alexa," and that way your device, let's say you have an Echo device or even on your phone, that using that wake word, the device got activated, and then it's listening for the sentence, what you say after the word Alexa. And you said, "What's the weather?" So as you said earlier, yes, it's recording that word or the sentence, "What's the weather?" It's converting that speech because you spoke about it, right? You did not type or you did not do Google search. You typed, or rather you speak. So it converting that speech into a text. It's sending that text to a server where there are tons of answers, right? So when you say, "What's the weather tomorrow?" it's trying to convert that into so what you ask is a question in a natural language, right? You did not say that what is the weather in New York City tomorrow, right? Or whether New York City, you did not ask specifically, but you asked that question in a natural language, like you speak to a human. What are you doing tomorrow, right? Similarly, what is the weather tomorrow? So based on that natural language question, it's going into its database. Based on the zip code where you are, it's using some weather data, could be from weather.com, could be from under weather, I don't know. It's retrieving that information and it's feeding the text back to that device, right? So far what you received is, when we ask that question, "What's the weather tomorrow?" It's converting that natural language into a computational language, retrieving the weather data, retrieving the tomorrow's data for that zip code, and giving in just a text format so far. Okay, it's still text coming into the device. And then the text get converted into speech again. And then it speaks, "Hey, tomorrow it's going to be 32 degree and chilly," right? So there are multiple things at the play. Speech to text when you started, then it's converting that natural language question, like "What is the weather?" into an actual question what computer would understand, right? And then it's capturing your local geographical information of the zip code where you are. And then it's giving you back the answer in a text format, but the device is converting back into a speech, and it's speaking out loud so that you can listen in your device. That is in a nutshell when Alexa or Siri or Google, when you ask something like this. Is it clear enough?
Yeah.
Yes.
So that is where, when we say NLP or natural language processing, it's practically this models are trying to understand how human speaks, right? Or at least those models are trained. And that is where actually it's a supervised learning, because we as a human have trained that model that, hey, when somebody say what, this is what you need to do. When somebody say why, this is what you need to do. When somebody say how, this is what you need to explain. When somebody say which, they means which place or which location or something like that, right? Because in our English language, there are many ways we are asking those questions. And that is where this NLP domain shines a lot. And whatever advancement what we are seeing in the machine learning in the last couple of years, or maybe 5 years, is primarily happening in the NLP domain. Okay, natural language processing, and we'll touch upon many use cases when we go into the actual practicality of it. The center in my screen is something called computer vision. Anybody knows any use case of a computer vision? Go ahead, Gyani.
So is it like Google Lens, or also some people have been developing some gadgets for blind people where a camera recognizes all the objects in front and help them walk?
Yeah, that is a very advanced use case actually of what you are highlighting. But we have seen computer vision in everyday life as well.
Yeah, traffic lights. In the traffic lights, we have the enforced camera.
Okay, that is one example. Yeah. Okay, what else?
In the security camera, we have, right? So it automatically detects the motion.
Yes. Okay, now we are going somewhere. Okay.
And auto driving.
Exactly. Auto driving as well. Yes.
Okay.
So yes, when we say computer vision, primarily we are, all of you are correct. Primarily, we are looking at a use case where a camera is involved, right? And that camera can do all kind of magic. And exactly some of those use cases what you define, right? You have like a Ring camera or a Nest camera in your home, or maybe at that doorbell or whatnot, and then it's recognizing that, hey, somebody is outside, and I think it's a person, right? Or maybe it's a cat. That cat you just had gone out of your back door is actually coming on your front door, right? I'm just teasing out, but primarily computer vision use cases are around where there is a camera at play. And there are hundreds, not thousands, maybe millions of use cases are there where anybody have heard of Amazon Go?
Yeah, I think I've heard of it. I think the store is that you just go and pick up whatever you want and then like pay on the way.
Okay. You don't pay anything, right?
No, I think I'm.
Yeah, so you
But
are
I
in
know that you
Seattle.
can.
You are in Seattle, Salman. So you should go and visit that Amazon Go store, okay?
Mm.
And just observe it. You don't need to buy anything, but go and observe it. But if you are not aware of Amazon Go store, it's in many of the major cities. I think in San Francisco, in New York, and in a couple other places as well. But and I think even they started selling the technology to some of the airport stores, where you just go and walk out, right? You pick something, whatever you want, and you just walk out. What it does, it's a combination of few things, but behind the scene, at least, it's a combination of camera and sensors, right? So when you enter to the store, you sign in with an app, and in that app, you come in with that app login into that into the store. And let's say you picked up a salad box from that store, or you picked up a granola bar from that store, and you just walk out. So as you are walking in the store, because of that multiple camera and sensors and whatnot, it's recognizing that this is you. As you are walking, it's recognizing this is you. As you are raising your hand and picking an item, it's recognizing that you picked up that item from this aisle, from this level, and this is the item you picked up. And if you don't put that item back, when you exit the store, it will charge your credit card. Right? So technically, you don't have any checkout lines. You don't have any cashiers. You just walk in, take the item, and walk out. That is, again, there are many use cases of computer vision, but that is, from a consumer point of view, is one of the few I have seen done very nicely. Similarly, that autonomous car or any of the modern car, where using camera, it's recognizing that somebody is on the road, right? If you're about to hit an animal, or if you're about to hit a person, that modern car with a camera equipped, it's recognizing that there is a person in front of that car and either warn you or even automatically stop it, right? So that's the computer vision at the end of the day. Any questions on a computer vision?
Nothing.
Okay. So you all have a homework to find out and then go to visit that Amazon Go store, or at least find out some of the use cases which are around all of this domain. Okay. I'm going to give that homework to you. All right. So we talked about NLP, we talked about CV. The third picture I have is more very generic. When we say data science, it's without data, you cannot do anything, right? Because whether it's NLP or whether it's computer vision, you need to have data to train that model or train those models, multiple of them. And that science of managing the data, whether it's all the way when we say data engineering process, where how you acquire the data, how you process the data, and eventually how you store the data before you start training your model, and how you create the features from each of this data, what you captured, and how you use those features to generate the prediction for your model is all about the science of data, or as they call it, data science. And the last two picture on the lower end I have is a car. We talked about autonomous car, but it's not just autonomous car which is popular. There are autonomous trucks. I believe between Phoenix and LA, they do run a truck which do not have a driver, or maybe they have a driver, but it's not steering the truck.
Yeah, I had seen that in the news actually. It's in the South Phoenix side.
Yes. So again, it's a combination of computer vision, a lot of sensors, a lot of reinforcement learning, right? Because the truck has, or that model which is in the truck had to be trained using that entire map of LA and Phoenix, and whatever that Route 66 is. Again, I'm just hypothetically saying it's Route 66, but whatever that route is between LA and Phoenix had to be trained tremendously using a lot of compute power. And then that model got deployed into the truck. And then I'm sure 20,000 times they may have driven that truck with a driver on, and then they have released that without a driver. Right? But it's amazing at the pace where technology is going.
Yeah, here we also have the Waymo cars.
Mm-hmm.
It's completely driven driverless. It's been years. Like since I moved to Phoenix, I used to see that. Probably before itself, they might have deployed it. It's part of the Google self-driving car, right?
Yep.
So you can book the car and it will come to your doorstep and take the car. It's kind of Uber, but there is no driver in.
Exactly, right. So why so many companies are investing into autonomous vehicle? Again, Waymo. Go ahead.
Yeah, so humans do the mistakes, and even initially the artificial intelligence also might make the mistakes, but it's better than human. Once they learn, once all the case studies are proper in particular region, we can try to reduce the accidents.
Okay, so that you can drink and drive, right? No, sorry, that was a joke. But yes, in a way, yes. If we can reach that intelligence of AI, where it's on par or almost there as human, we do get distracted by one or the other thing, right? Maybe there is an accident on the other side of the freeway and we get distracted and suddenly we end up bumping up the car ahead of us. It happens. We do get distracted while computer doesn't, right? And the second thing is, if somehow we are able to offload this task to somewhat autonomous, we can do other things. Like during the commute, we can start coding. Just kidding. Don't do that. But at least the goal is to free up the human from mundane tasks where we don't need to pay enough attention, and so that we can invest our energy in a better task. Okay, and finally, that the last picture on the top right is more about, I think somebody mentioned about deep learning. So when we say deep learning, it's again a part of a machine learning as a whole, right? So if we think from layers to layers, and then if we think AI is one layer, right? From let's say if AI is an onion, for example, right? Then the AI is the topmost layer of that onion, and if you peel that onion, then you get something called machine learning. So machine learning is kind of a subset of what we call AI, right? And deep learning is even further into the deeper layer of machine learning, primarily where it's think of human brain, right? And if we are thinking from a human brain point of view, it's made up of a certain networks where neurons are sort of connected with each other, and that neurons talk to each other, and based on those neuron communication, our brain operates. So similarly, deep learning is kind of designed in a way where similar to our brain, where neurons are connected with each other as a layers. In this scenario, what we see is kind of a three layer. One is the input layer, there is something in between, and there is an output layer. But it can be 100, can be thousands of layers as a part of your model. And as we go further into the course, you will learn more about where the deep learning are applied, and some of the example what we heard today are clearly coming out of deep learning, like generative text or generative image are the use cases of deep learning. Compared to the autonomous vehicle is an example of computer vision to start with. And then people applied deep learning into computer vision, and then they started developing more and more use cases, right? So we will touch upon quite a bit of this use cases per se as we scroll through the class. I just wanted to throw in these terms so that you are aware of when you hear these terms next time. It's not a foreign terms to you, and then you know at least we talked about it. Cool. Okay, so now we are getting into the heart of what is MLOps. And I'll leave you with one diagram. I hope it's a diagram. Okay. So this is the life cycle of a machine learning project. Any machine learning project typically, again, I'm saying typically because it's not necessary all the machine learning project would have something like this, but most likely each project should have a scope. One thing I'll tell, since all of us are coming from a technology background, machine learning is not a technology problem. It is a business problem. Think of any machine learning. It always starts with what is your business problem. And that business problem could be, okay, I want to have this truck go from Phoenix to LA. Or I want to convert my speech into text. Or I want to convert my text into speech. Or I want to write this blog automatically, right? That is a business problem. What is technology problem? It's like, how do I scale this? How do I make it reliable? How do I make sure that data is always secure? Those are technical problems. But machine learning problem always starts with a business problem. So before any ML project happens, you want to define what that project is. Or as a project sponsor, if I'm the project sponsor, I want to have that scope predefined and say, okay, this is what I want to do. Based on that, let's say if I'm the project sponsor and you are my team, I'm going to ask each of you to come up with few things. One, I'll ask maybe Shri that, hey, Shri, go and find data. Let's say I want to solve this doorbell. I'm just taking an example. It just came to my mind. There is a doorbell, right? I mean, Ring or Nest or any doorbell you take it. And nowadays it's a video doorbell, right? Where if somebody is at your door, it will recognize it and will say there is a person in front of you or in front of your door. So if I want to solve that problem, so business problem is I want to create an artificial intelligence based doorbell, right? Doorbell existed maybe 100, maybe 200 years ago as well, right? Doorbell is not something new, but AI based doorbell is new. And why I want it? Because I want to know who is at the door. Why you want to know who is at the door? Because I work 9 to 5, and if somebody is coming at my door, I want to know who that is. Okay, that means you want to take a picture of that person. Oh, yes, yes, yes. I do want to take a picture of that person. It's just not that I want to know whether somebody is there, but I also want to know who is there so that I can report to police if some thief or somebody is coming into my home. Okay, so that's my project where I want to find out somebody is at the door and I want to find out who is at the door. That means I need to have a camera. I need to have some sort of a model trained where that camera is able to identify somebody is at the door and it's able to distinguish whether that is a person, that is because of the sunlight, that is because of the moonlight, that is because of the pet coming in my door, that is because somebody just walking in my sidewalk and somehow got captured in my doorbell or whatnot, right? So that is my scope of the project, or when I say define the project. And then I'm asking Shri, okay, Shri, you need to go and grab the data and identify to build my model. So he will go and grab some data. Maybe some data is from public domain. Some data he may have to purchase from somewhere, but many of the data may not be labeled. So what he needs to do is he needs to label the data. He needs to organize the data which is primarily because we are doing some sort of a picture-based recognition. That means he needs to capture a lot of picture data. And when he's going on the internet with the picture data, public data has a lot of garbage. So he has to label from that picture that who is human, who is cat, who is dog, or apply some sort of a logic with a model to identify that. And he has to organize the data because quite often the data is coming out from internet or some other places and it may not be well organized. Then he's handing off the data to Nishit and telling Nishit that, hey, Nishit, here is the data, you go and build the model. So Nishit said, okay, I'll go and build the model. So he goes to the internet, finds a model which is already pre-trained using millions of images with pictures and whatnot, and adding some additional data, what has been private data or purchased data by this company. Nishit trains that model. Again, it's a supervised model. I'm trying to be specific here. And once that model is trained, Nishit is evaluating that model to see whether he's able to recognize the right people as a part of that model or not. And then he's sending off that model to Salman and telling Salman, hey, Salman, go and deploy that model in production. So Salman is deploying that model in production, but as a part of that, Salman realized that this is a model which needs to go into the doorbell. The doorbell is very small. It's like 2-inch doorbell. How you are going to fit that model into 2-inch doorbell? So that means he needs to work with Gyani to figure out how to deploy that model at edge or at the edge. You learn these terms: model at edge, inference at edge, deployment at edge, and then whatnot. And when we say edge, it's like anything which is not running on a server, but that model is running on that small computer, which is sitting in that local mode. So your doorbell may have a small computer itself, and it's doing that prediction on its own locally, and it's not reaching out to any servers on the internet because it may not have an internet connection and whatnot, right? So once this entire life cycle is over, and then once that is identified, I change my mind, right? So once everything is deployed, it's running fine and nicely in a doorbell. Now I changed my mind and I said, hey, now Amazon is delivering the packages using drones. So I don't want to only identify human, but I also want to identify if drone is coming in my doorstep, right? So if that happens, and if I change my mind and if I change my scope, what happens? Anybody wants to comment on what happens when I change my mind and change the scope from human to drone? Okay, am I still here? Can you all hear me?
Yeah.
Okay.
I think we'll have to change like everything. I think the data, the model, we'll have to go all the way to the beginning.
Okay. You are close, very close, Salman. Gyani, you want to say something?
No, nothing.
Okay. So yes, in a way, when my scope is changing, right? Initial my scope was only for human, but suddenly I decided that I want to have a human plus drone to be identified. That means my model has to change. That means my data has to change as well, because my model was trained using certain data set. So my entire life cycle has to be done again. And that new model has to be deployed into that doorbell, right? Am I making sense?
Yeah.
So that way we are sort of doing this again and again. Now, this is just one example I give you. There are millions of examples where ML is in practice today. And that model get changed every day because of data change, because of the model change, because of some drift happened. and whatnot. But I wanted to leave you with this life cycle picture in your mind. And when we come back next time, we will review this life cycle and we will go through one use case of what happens in the real life. Okay, with that, I'll pause here and then see if any questions anybody has. Okay, if no question, let me stop the recording, and I hope everything was clear from a ML lifecycle point of view and some of the fundamentals of machine learning and AI.